Shekhar, you can start.
Good morning, Ash. I think
Yeah. Good morning, Shekhar.
we're starting now at 12:30.
Now, 12 o'clock.
12 o'clock. No, that's
11:30 postponed to 12.
Hmm. Start.
Yes,
Pratik
yes,
has
start.
joined.
Yes,
Yeah, I
Pratik
am
has joined.
here. Hi, everyone.
And Jigar also has joined.
Hey, morning.
Morning. So, good morning, everybody. So, let me introduce two young speakers today. First, I'll start with Jigar, Jigar Patel. Jigar has done his BSc in physics from Winson College, and then he went on to do his MSc in data science and analytics at Maynooth University, Ireland. Then Jigar is an data enthusiast with a solid academic background and a knack for solving real world problems through analytic and programming. Now based in Dublin, Jigar works at a Mater Hospital as a data analyst and Python developer, where he combines his skill to make a meaningful impact in healthcare. So welcome, Jigar. Uh, and what time is it, Jigar, now there?
It's 6:37 in the morning.
Okay, so we should really appreciate them with the whole day's work and they're joining so early for us. And then coming to Pratik. Pratik did his BSc from Wilson College, Masters from Somaya College, and he has done his MS in data science from Southeast Technology University. Uh, Jigar has worked at different places. He has worked at TIFR as an intern, uh, and then he has worked
You mean
there as
Pratik?
a. This is Pratik. Yeah. Uh, this is sorry, I missed. Okay, this is about Pratik. Okay, Pratik has worked at TIFR as an intern. Then he has done a project at TIFR on fabrication and characterization of resistive plate chamber for cosmic muon trackers. He has done a research project also at TIFR on optimizing a radio telescope array design to detect different events. He has worked with IABT workshop, taught basics of Python, some libraries like NumPy, uh, Panda, Sky, Sci, Python, and so on to solve physics problems. He has attended summer school at Caltech, participated in an Astro 2002 astronomy software development at Caltech. Uh, he was a teaching assistant at Northwest University, teaching astronomy software development, and currently working as a data analyst at I, AIB Ireland Bank, developing innovative solutions for banking sector. So I welcome Pratik. Uh, so and hand over the session to Jigar and Pratik.
Thank you, sir, for the warm welcome. Hello, everyone. I have shared the Getting Started notebook yesterday, and I hope you all have had time to go through it. So, in that basic, I had just put numbers and strings. That's it, just to get you started so that you can see how the Jupyter notebook works and how the UI of the notebook is. And I am assuming that as it was a prerequisite, all of you are aware of some things of Python. I'll share my screen.
Yes.
Is this visible?
Yes, it is visible.
So we'll continue where we left off in the yesterday's getting started notebook. And here I have created a template notebook just so that you can see what all things are coming up next. A proper notebook which I have created will be shared with all of you after the lecture. So you don't need to make notes or write all of this now. What you can do is you can create two windows side by side, half of the screen, and you can code with me along. And because I'll be giving very simple examples. So if you're using Colab, you can open next window on the half of the screen, or if you're using Jupyter Notebook, any tool is fine, any platform you're comfortable. Some people are also using VS Code, I think. So now let's begin. So you are all familiar with strings and numbers. Those are the basic object types. Other object types are tuples, dictionaries, lists, and sets. So we'll just quickly go through it. And this is just sort of a revision for people who already know Python. So tuples are used for storing multiple items in a single variable. So to create a tuple, let's just say I'm naming the variable t. I'm not able to type. Okay. So tuples are enclosed in round brackets. So if I say one, okay, wait, I'll reshare my screen actually. I'm not able to type on that. So this is a tuple. If I print t, it will just be a round braces and elements inside of it. Now, tuple is a heterogeneous object. So like it can have strings in it, it can have Boolean values in it, it can have strings and numbers together. Like I can have 1, 2, 3. That will also work. The only difference between a tuple and a list is tuples are immutable. Like I cannot change any one of the elements in a tuple to some different value in an iterative loop. So once I define a tuple, it's fixed. So it is this type of thing is useful when you are defining some constants in astronomy where you want to keep it fixed and so on. So now let's go ahead with dictionaries. One important function that you can use with tuples is there is function called length. So length will give you the how many elements are present in that tuple. So it says that there are 6 elements in it. Once again, a reminder for all that Python is a zero indexing language. So the 1 is not the first element here. So this is a 0th element. 0, 1, 2, 3, 4, 5. So if I want to count it, then I will count starting from 0. The first element is always the 0th element. So the next is dictionaries. Dictionaries are very useful because you can store key and value pairs in it. In keys, they must be unique and they are immutable. They can have strings or numbers or tuples. And the key value, you cannot have the same key value for multiple elements. Every key value must be different. Values you can have same. Values also can be of any data. So the basic syntax of a dictionary is you have to enclose key value pairs in curly braces. Like this is an example dictionary which I have written here. So in curly braces, I have written key 1, value 1. Key 1. Sir, I'm not able to type in between. Is it because of the waiting room that is popping up? Is there any way to disable that?
Hello, sir. Should I disable the waiting room?
Yeah, actually, because it is, I'm not able to type in between. Again. A window is popping up in the background.
Now it should work.
Okay, thank you. So this is a basic format, like a key one, semicolon, and value one, comma, separated by the second element, key two, value two. So if I run this, you can see it's a key value pair. And now I can take example key one. It will give me value one. And similarly, if I type key two, it will give me value two. Now, a dictionary has these options. I can clear the dictionary from keys. I can get items of the keys. How I can see this sort of helper functions is, after example, if I just type dot and I press the tab key, the tab key will suggest me what all functions can I use on the object, dictionary object. So you can explore this even by going through the documentation. So items will just give me in enumerated pair of key and value pairs. So example dot items will give me key value as one. The first I comma j will be key, and then the second pair will be value. We'll see this in the for loop ahead. So the next object is set. Set is also defined by curly braces, and it can get confusing, but the difference is the dictionary has key and value pairs, whereas set has just elements in it. Uh, so the set elements. So set is a keyword, so we cannot name a variable as set. So I'll just say set one. 1, 2, 3, 4. So now if I print set one, I can see that all these four elements are printed. And if I print set two, you notice the difference that the set can have only unique elements. Even if I have put three times, when I print set two, it is only considered once. So the set is useful object when you want to get unique elements of one whole big column. Suppose you have a big CSV file of astronomical objects, but the same object appears on multiple rows, and you just want to see how many unique you have. So in pandas, there is a unique function, but you can also quickly convert that whole column to a set and see the count of it. So set will only consider one object, one element once. And even just like I've showed you in dictionary, set dot will also give you options of what all things you can do with it. So in set, you can have difference, you can discard, there is intersection, there is superset or is a subset of some other set. And we can see all that. So I'll give you a quick example here. So suppose I have set A 1, 2, 3, 4, and I have set B of 3, 4, 5, 6. Let me run this cell differently. Now, if I have to take union of a set, I can do set A, and there is something called as pipe operator. It's a straight line, and then set B. So this pipe operator, I'll just write in comments that this denotes union of sets. So this will combine both of these two sets, but 3 and 4 are repeated. So it will just consider it once. So this is union. To take intersection of two sets, it's just set A and percent set B. This will give only the common elements between the sets. If I have to take difference of the sets, then it is set A, then what do you call it, a caret operator maybe, and set B. This will give me intersection, so just 1, 2, and 5, 6. It will remove the common elements. And what else? On set, we can do operations like this. Print, do we have 7? Do we have 7 in set A? I can ask with this n operator. N is a reserved keyword in Python. So it will say false, that 7 is not in set A. And similarly, I can also put not in. It will say true, that 7 is not in set A. So it's like Python is a very readable language. It's what it is, how you read it. After this, let's move on to lists. So lists are enclosed with square brackets. Now let's revise the difference. Tuples are with round brackets. Dictionaries are with curly braces, but it has key value pairs. Sets are also with curly braces, but it has just elements in it. And lists are enclosed in square brackets. So lists is an unordered collection of elements. They are very similar to tuples, but they are mutable. By mutable, I mean if I want to change the third element of the list object, I can do it. I can just say L of 3 equals to something else, and it will change the third element. We can access the elements just as tuples by using the index. We can use something called as append. So if I use L dot append whatever value, that value will be added to the list. Now this is very useful when we do iterative programming and when we want to keep adding new data to the list. We can also add multiple lists inside a list. So we can have nested lists. So let's just quickly see one example. I'll just copy this. This is a good example. So the list L has these elements. It can have numbers, strings, boolean, floats. And to access any of that, we can do just indexing. So this will give me the 0th element, that is the first element. I can also go negative indexing. If I go -1, it will give me the last element. If I do -2, it will give me the second last element. So as it goes from 0, 1, 2, 3, 4, it also goes backwards, like -1, -2, -3, -4. What else? So we can also see one new thing, that is list comprehension, because you'll see this frequently in AstroPy documentations, or if you look for any Python notebooks which are done by professionals, they use list comprehension very often, and it might be confusing if you're not aware about it. So we'll go to the control flow and for loop, but I'll just give an example here of how list comprehension works. So suppose if I have some numbers, say I have a list of numbers 1, 2, 3, 4, 5, 6, 7, 8. If I want to have squares of numbers, if they are divisible by 2, else I just want to keep them the same way. Normally, what I would have to do is I would have to create a new list. I'm creating an empty list here. And then if I want to take the square of only the numbers which are even, I have to write a for loop. So how for loop is written is that we will see in control flow where I explain properly. So here I'm saying for n in the list numbers. So for each element in the list numbers, I am adding a if condition. If that n number modulo operator 2, modulo checks the remainder of the operator. If the remainder is 0, that means it is exactly divisible by 2. Then I want to append that value square to the list. So I hope this is clear that if the number is divisible by 2, this just checks the divisibility. If the remainder is 0, that means it's divisible by 2. Then I want to append that number square to the list. Else, what I would do is I will just append the same number. So in Python, when we write such control flow, like the conditions, the indentation is very important. So if I put this colon and if I press enter, you see automatically there is an indentation of 4 spaces. In the next thing, if I press enter, again I get indentation of four spaces. And if I mess up this indentation, then it will throw an error. So this is very important. So let's see what's the output of this. So this is giving me square of even numbers. So this is giving me 2 square, 4 square, 6 square, but it is keeping the odd numbers just like that. Now what list comprehension is, I can do this entire thing in one single line inside the list itself. How to do that is, we can just say even squared equals to, instead of creating an empty list, in that list itself I will write square n for n in numbers. This is called as list comprehension, where we write the conditions inside the list itself. So if I just say n square for n numbers, it will square all the numbers in the list numbers. But if I want to do exactly like this, if I want to square only even square, I should have not named this even square. This is just square. This is not even square. If I want to just square the even numbers, then I'll have to write n square for n in numbers if n mod 2 equals to 0. So see the difference here. If I give the same condition like n square for n in numbers, if that n is divisible by 2, this is giving me even squared, but it is not printing the others which are odd, 1, 3, 5, 7. If I want to do exactly like this, then I have to write it this way. N square if n mod 2 equals to 0, else n for n in numbers. So this output is exactly like what I got with this huge 4 lines. So I can compress these 4 lines into this one single line. Now notice the difference that if I don't have a else condition in my list comprehension, my if condition goes at the end. I cannot write the opposite way actually, like n square if n modulo, it will throw an error. But if I have an if else condition, then it comes before the iterable. So that is about list comprehension. That's something you should know. If you see something like this, then it is just a loop, like a for loop or iterable compressed into a list. Now let's go with control flow. We'll see more about loops here. So we have if else loops, we have while loops, and we have for loops. And all of this we can use with break, continue, and pass keyword. So break is used to stop the loop while the condition is true, and continue is used to stop the current iteration and then continue to the next iteration. We'll see this in
Pratik,
examples
just a
how,
minute.
yeah,
Just a minute. There is a possibility that there will be students with different levels of understanding of Python.
yeah,
So I think Jigar is already in the meeting, and anybody has a problem picking up with the speed. Okay, you may ask questions in the chat of the Zoom meeting itself, and parallelly Jigar will answer that. But as Pratik has said, please parallelly start working this notebook after the session is over. I think Pratik is going to upload on the Google Classroom. Okay,
yeah, I will do
but
it. Yeah.
making your session time, your learning time is very important. So do not get distracted by the other things. Pratik, you can continue.
Yeah. So I believe Jigar is already answering some of them. Okay. So we'll see some examples about control flow. Also before that, we know that the operators are plus, minus, division is slash, multiplication is star, and power is double star. But if we want to assign a value to something, we use single equal to. If we want to check the equivalence, then we use double equal to. So if A equal to B, if A is 1 and B is 1, then it will give me the output true, which is a Boolean. So yeah, it will say that it is equal. Then I can also check non-equivalence by exclamation equal to. This is basically like crossing equal to, not equal to. Then less than equal to is just like logically how it would be. And in Python, else if, like if we want to add multiple conditions in if loop, if statement, then else if is spelled as elif, and the last would be else. So let's just see quickly with an example, very basic example. Suppose we have A4, and if you want to print if A is less than 5, then just print that A is less than 5. Else if A equal to 5, print A is equal to 5. And the last is else, print is greater than 5. So 4 is less than 5. So we're going inside this statement. Now this is format strings. So you should have seen this in the yesterday's notebook that I shared. So if I want to replace my print statement with some variable value, we use this format thing. So we write s just before the string begins, and whatever we want to replace with a variable name, we enclose that in curly braces. So this is called format strings, and this will be useful a lot even in your assignments and if you want to print your outputs in a nice format. So if I change this so something 8, then it goes into this else block because none of the conditions satisfies. Like this is not true, this is not true, so it goes into the third block. Okay, so I hope this is clear. The next is for range. So for
Okay, here, Pratik.
yeah,
Here, just I'm allowing people to unmute themselves and ask. So if there is any very specific question, please do that because these 2 days are going to be on the basics, and it is better that everybody understands what is happening, so that next week will not be a big issue.
Yeah,
So
sure.
if anyone has a problem, please directly ask on the screen. Parallelly, of course, on it on the chat, you can do that, and Jigar is handling it. Yeah.
I think you can raise your hand to ask a question.
I mean,
Then
don't just
another.
unmute, because then it is also disturbing the background noise. Unmute if you want to ask.
I've seen some comments that the pace is fast. I'll try to go a bit slower, but the reason I'm having quite a fast pace is because I have to cover a lot of things in the basic stream. So these all will be prerequisites, and of course, I will share more detailed notebooks with you. So in your own pace, you
My
can run each of
my
those
my
sessions.
suggestion, Pratik, my suggestion is
Mhm,
because this, I mean, lots of things are part of prerequisites also.
mhm.
Instead of going into detail, show few things in greater detail rather than doing lots
Yeah,
of things. And
yeah,
the other things can be put on the notebook, because these
notebook,
are
yeah.
part of prerequisites, so that we can focus mainly on the tasks of what is at hand.
Yeah. So main thing is we want to reach towards NumPy and Matplotlib because that would form the base for tomorrow's sessions and further
Yes.
sessions. So if there are no questions, I'll just continue with for
Sir,
loop. Yeah, yeah,
why in the print there is F used before the before inverted
yeah.
comma?
So this is something called as formatted string. So this is used when we want to pass a variable value in our print statement. So you see, if I have written here, if a is less than 5, my a value was 4 before, right?
Yes.
And if I have to print that if a is less than 5, then if I say print 4 is less than 5, because I have put a equals to 4, then all of these would be 4. That works. But now if I change it to 8, it is still printing 4 is greater than 5 because it's still 4 here. I want it to be dynamic, right? Whatever the variable a will be, I want that statement to be printed. So we use this small f we write just before the string so that it fetches for the dynamic value of that variable. And for that, we enclose that in curly braces. So
Okay.
whatever we enclose in curly braces, it will be replaced with the value of that variable a.
So can you give quickly two examples? One without formatting, one with formatting. Just one after the other.
Yeah, sure. Suppose if I have b equals to 6 or something. So if b is less than 5, I want
Better
to.
use floating number, because floating number gives you better idea about why formatting. I think that B should be outside.
No, that's correct. So that's what I wanted to show. Now, if if
Okay.
my variable name is b, and if b is less than 5, then I'm going to print that b is less than 5. But it won't print the value if I'm not using format string. It will just say b is less than 5. If my code is like 1,000 lines, then if I'm printing b is less than 5, how would I know what is b in my code at that instance? So for that, we use format string. So this will just print the value of the variable, not the variable name itself. And if I change this value to anything, it will work accordingly.
If you can also show that print B comma and then the message, because that is also there, but that is not formatted.
Oh, okay, like that are you talking? Okay.
Yeah.
Let me think of some example.
No, just put the same thing here.
So let's just say, what can I put some number. This is some random number. It can be anything. Is less than 5 with value of C as C. So in format string, we can have multiple variable names enclosed in curly braces. So I have the C 6.8 and I'm printing that if B is less than 5, then I want to print that B is less than 5 with the companion value C as 6.8. So it will print 6.8. Now this value can be anything. It can be 10, it can be 5, and it will update accordingly in the print statement.
No, Pratik, my suggestion was just in that statement, write another statement after that first statement of print F before else. Right, print in the bracket B, just write no non-formatted.
Okay.
B then comma non-formatted, just B.
It is not formatted.
Outside the quotes. B comma and then quotes.
Oh, like that are you? Okay. So this is another way to do it. So in print,
And
we
then
can
you can
print.
write with value of C as and then outside the quote C.
Yeah. So it's the same thing as writing this one.
But you can.
But formatted string is better because we can use it for other purposes also. So there are multiple ways we can print statements actually. We can also
What I will further suggest is if you put B and C as the two integers, that will give you a large number of floating point, and you want to stop at after 3 decimal places or something like that. That is where formatting string becomes useful, right? So,
yeah, we can use round functions inside it.
Okay.
Yeah. We'll see that later. Someone has raised hands, so if there are any questions.
I mean, there is a question that I am I shouldn't interrupt. Thank you for that. I was just trying to give an example where the formatted string can be more useful. Okay, that's why I am stopping this. Yeah. Okay. Please go ahead.
Okay. So let's go with for range. So let's just take a basic example. For X in a string, let's say I'm having a string astronomy, and I'm just printing that.
Excuse me, sorry to interrupt. I actually had a doubt.
Yeah.
In the last, in the formatted string, how do we perform any mathematical operation if we want to?
You can do B plus C. That will work. So see, it will happen 13.4.
And with numbers, it's B plus 1 if you want to, right?
Yeah, you can do that.
Okay.
That will work. Yep.
Okay. Thank you.
In fact, in formatted strings, we can also have, if you have defined some functions, which Jigar will take in the second session later today, you can also pass a function in formatted strings. So this formatted strings is a very versatile way of printing dynamic variable values. We'll see that later, more advanced stuff. So let's go with for. So for loop, we can iterate over a sequence or execute a set of statements once for each item in whatever we have here. So here the syntax is for iterable in whatever we want to iterate through. So for x in astronomy, what it will take is it will take each element and do whatever you want here. So I am printing x. If I do x dot upper, then it will convert all of these strings to upper syntax, and it is doing it for every element, but it is printing it on next lines. It won't print just like that because it is a iteration. So for every iteration, the first iteration A, it is printing A. Second time it is printing S, then T. That's why it's coming on new lines. Similarly, we can do with numbers like for I in range 10. So range function will just give you a range of values from 0 to 10. It starts from 0. I can print I and it will give me 0 to 9. So this is actually 10 because Python is a zero indexing language. Python starts from 0, not from 1. I will probably repeat this multiple times just so that everyone can remember, because this is the first element and the 10th element is the number 9. In range, I think this works. So in range, the first element it will start with, but the second element is not included. So this is called as inclusive element and exclusive element. So it will start from 4 but end just before 10. This will not include 10. And this is reflected in everything that we do in Python. Whenever we are using indexing or anything, the first element is inclusive and the second element is exclusive. So if I also want to print the last element, I will have to give one extra index. We'll see that later in examples. We can also have in loop, we can have operations like for I in range 0 to 10. I want to print I square, say. But if I want to skip alternate, then I can do in the steps of 2. So the syntax is inclusive index, exclusive index, and this is the step count. So it will take 0, it will skip 1, then it will take 2, skip 3, then it will take 4, and so on. So in steps of 2. If I gave in steps of 3, then 1, 3, 6, and 9. So this is a step count. We can skip those elements. Now let's go with while loop. I'll just give quick one examples of each of this. So while loop executes the statements, whatever you write in it, until that condition is met, else it will break. So let's say for while loop, we need to have some counter which keeps the track of how many loops it has completed, else it will get stuck in the infinite loop and it won't, the cell execution won't finish. In that event, if something like that ever happens by mistake, in Jupyter Notebook, you see there is stop sign here. So this stops the runtime or the kernel and it restarts it. So you can use the stop sign. In Collab also there is stop sign. I don't remember where is it in Collab. But yeah, it's there. On the right top, there is also a runtime window in Collab, so you can stop it from there also. So while I is less than say 10, I want to I is I plus 1. I want to just add 1 to it, and I'll just print I. So this will print 1 to 10. Now this can be also done I plus equals to 1. It is the same thing as I equals to I plus 1. So this plus equals to will keep adding to the I. We can also have minus equal to and so on. Now in while loop, we can use statements like break and continue. If you want to break a loop, let's just see quickly what the difference is. I'll use the same example. While I is less than 10, I want to print I, just like that. But if I reaches the value of 5, then I want to break the loop. and I'll continue with incrementing the value of I here so that my loop will continue. Now this break statement just breaks at this instance itself when it reaches 5. It won't go ahead. But if I write continue here, then it is stuck in an infinite loop because I continued and I did this here. So that you stop now. And if I put this thing before break, then I use continue. Now see what happens. So while I is less than 10, I'm incrementing the value of I. If it reaches 5, I said continue. When I said continue, it will go back to the while. It will check if I is less than 10. So it has printed 1, 2, 3, 4. It reached 5. I said do nothing when it's 5. Continue. It skipped the printing of 5. Then it continued with 6, 7, 8, 9, 10. So break will break whatever point you reach and then do nothing ahead, but continue will go back to the iteration condition while it will check again for the while condition. So you can use this break and continue. So for example, if you want to not perform any mathematical calculations, if some conditions are satisfied, you can just say continue and do for others. If you want that if my condition is reached, then do nothing, stop it there itself, you can use break inside the while loop. Okay, so this is just the building blocks of Python basics. And now we'll go ahead with NumPy. I hope I'm good on time. How long has it been? 50 minutes, I
It's
guess.
12:52.
Okay.
This session will continue up to 12:30, 1:30.
1:30. Okay, that's fine. So in NumPy also I'll give one example each, but in the notebook that I will share with you, it will have more detailed examples. So NumPy is the most important package I would say in Python, because if you do any kind of data analysis, even in AstroPy, NumPy you will always need. It is used for numerical calculations. It is fast. It is based on C++ in the background. That's why it's fast. And NumPy has arrays. So like Python has list, NumPy has an object called array, which is a much faster way of doing calculations on a list of things. So we'll just quickly see some examples. You can read this on your own pace whenever you get time. So importing any package in Python is as simple as just typing import NumPy. And as NP, it means I'm importing NumPy as an alias. Alias is just I'm telling I'm telling Python that I will be calling NumPy NP in my code. So if I say NumPy has a pi value, so if I say np.py, it will give me value of pi. Now let's say basic array. So if
Sir, can you please repeat the meaning of that NP, sir?
yeah, so NP is an alias. Alias is that I'm basically telling Python that henceforth in my code, I will be calling NumPy by the name MP. I don't want to type NumPy every time, right? So if I'm importing any package like import matplotlib, it's a big name. Import NumPy, it's a big name. So every time I will have to type numpy.py, numpy.array, all the functions. So I'm just telling Python that instead of typing NumPy, I'll be typing it as NP henceforth. So I'm just importing a package as some name. It can be anything. I can have NP as n. If I do that, henceforth I will have to type only n. But how do you say it? It's like everyone is used to using NumPy as NP in all the codes that you will even see online. So everyone just uses NP. It's like a standard practice now. So let's see how an array object looks. So np.array, I can pass a list, I can pass a tuple, it can be anything. So A, if I print A, it will give me array. It will tell me that it is an array of these things. And if I print A, it will just give me in a list format, but it is not a list. You see the difference is there are no commas in it. It is an array of objects. It is, we can do things like this, A into 2. It will multiply each element by 2. We can do mathematical operations on the array as a whole. We'll see that for examples further. Now, as I said that lists can have nested lists, like you can have a list of lists. Similarly, in NumPy, you can have a NumPy array, which is multi-dimensional array. So dimension is kind of a depth in which you go. So zero-dimensional array is just a scalar value. By that, I mean, if I say A equals to np dot array, just 9, it is just giving me array 9. So it does not have a list, it is just a single value. It is a zero-dimensional array. And I can check that by using this function called ndim. Ndim is n dimensions. So a dot ndim will give me how many dimensions are there in my array. So it is giving me that it is a zero-dimensional array because it's just a scalar value in it. Now, what will be an 1D array? 1D array will be an array which has zero-dimensional arrays as its element. Like basically, this is a zero-dimensional array. And if we have a collection of zero-dimensional arrays, np dot array, take the first example that I showed. So each of this 1, 2, 3, 4 is a zero-dimensional array. And now if I say a dot ndim, it will say it is a 1D array because it's a collection of this. And then how about two-dimensional arrays? A two-dimensional array, I will have a list, and inside that I will have two lists, 1, 2, comma, 3, 4. Now if I print A, it looks like this. And if I do A into 2, it will multiply each element. So whatever numerical calculations are due on any dimensional arrays, it will be applied to all of them. And I can have 3, 4, 5, 6. But if I have this, it will throw me an error. So when we create multidimensional arrays, what we have to keep in mind is the requested array is an inhomogeneous shape. This is the error that is showing, value error. The detected shape was 2 comma in the inhomogeneous part. So it is telling me that the first shape is different than the second shape. We cannot have that in a two-dimensional array. The shapes should be similar. So if I have 4 elements in my first array, the second array should also have 4 elements, or I'll have to delete 2 from this. The shape should match. Now let's see 3D arrays. How to create list of 3D arrays. So 3D array will be a list containing a list containing a list. So you see how I keep track of it is I count how many brackets I'm using while creating a multi-dimensional array. So if I have 3 brackets, it means it will be 3-dimensional array. So let's just create quickly. 1, 2, 3. The commas and everything is something that we need to be careful of while creating it manually. This you won't be ever doing that. You have to manually create an array. You will always use a loop or something to create these arrays, but this is just for demonstration. So this is a three-dimensional array. So in three-dimensional array, you have this is one array. Sorry, just a minute. This is one array. This is second array. And you can have more of them like this. But then each of them are consisted of three elements. And each of those elements are consisted of more three elements. That's why it makes it a three-dimensional array. And we can check that by just saying a dot and dim. That is 3. Now there is another function called shape. It will give me the shape of an array. So what does shape tell you? Shape tells me that I have this a numpy array consists of two elements. That is this one and this one. Each of those two elements has three elements. That is each of these lists. And each of those three elements has three elements. That is 1, 2, and 3. So this is giving me the shape of the array. Now, where will this be useful? Suppose you have an image and you have an image consists of RGB channels. Suppose you have a 256-bit by 256-bit image. So you have three numpy arrays, each of one channel, and the shape is 256 by 256. So in that way, numpy arrays are very useful because we can directly do calculations and do manipulations on that numpy arrays. So we can also plot an image out of a numpy array. Maybe I can show you that example tomorrow, now that I've mentioned this. So I hope till here it's clear. I'll just give a moment for you to ponder and see if you have any questions about this.
So arrays will be used the way matrices are used, right?
Yeah. So we in arrays we also have this dot product and inner product. Then matrices we also have determinants. We have transpose. Everything can be applied on it.
Sir,
Yeah.
can we combine two arrays? Like
Combine in the sense.
combine in the sense two array forming array 4-dimensional, like
I'm not sure if we can combine it straight away. Let's try. So you are saying if I have this.
We can multiply arrays.
Yeah, we can multiply. We can do any mathematical calculations on it, but not combine as such. Do you mean that you want to merge the two arrays?
yes, merge.
I think what we can do is matrix multiplication. So
Yeah, matrix
like
multiplication can be done. Then you can also have a mean of an array.
maybe
I'll
we
have to
can
check
try
actually.
transposing A and multiply that with A. Would that make sense?
I think what the question was, if we can have, suppose A is 1, 2, 3, 4 and B is 1, 2, 3, 4. Can we have two sets of it combined? So
Union of two arrays, I think.
yeah, that's what I think. That no. There must be something. I'll have to check.
I'm not sure, but isn't there some array add something operation?
The add operation is there. A plus B will work, but it will add the elements. But I think what the participant was asking was if I can have two rows of 1, 2, 3, 4 inside the same array.
Oh, basically appending one array with
Appending
another.
one array to other.
Yeah.
Yeah. Let's take a look.
You
I'm
can
not sure
do
if
it
it
by
will work.
using
No,
Jigar.
it won't.
Can
Block
you create
matrix.
a third array with higher dimension and then put element as the name of these arrays?
Sorry, what?
Can you create a third array of that higher dimension and then as elements
Pratik,
put these names A and B?
I'm sorry to
Is it
interrupt, but
possible?
I think you can append two arrays like np.append array1 and array2.
NP
That's the
append
thing.
is there? Oh yeah, it's there. I have never done this. I don't know where this will be used, but yeah, append function is there. But it is not giving me the proper shape. See, A and B are unraveled. It is the array is flattened here. So if we use append, then we won't retain the dimensionality of it.
No, would have the same dimension, I am afraid. If we have two brackets inside one array, that means it's a two-dimensional matrix.
Hello?
Can you write C as np dot array and in the bracket A and B, A comma B?
No, that won't work.
Sir, what about the unary AND operation?
That is not a set, right? But let me try. I have never done this. No, see this AND operation, it is doing element by element. So it is checking if 1 and 1 is there or not. So element by element it's doing. Not giving error, but yeah. I'm sure there must be some way, but if you want, you can Google it. I've never used something like that. Anything else, or should we move ahead?
Someone just mentioned concatenation. I mean, can we try it in arrays?
Like I know pandas has concat, bmat. I've never used this. Let's see. This will make block matrices. I don't know if bmat is a function. Anyway, you can Google this on your own. If you ever have to use something like this, then I'm sure you can find answers. Let's go ahead with accessing elements of an array. So let's just run this to that. Also, maybe I've not mentioned this, and most of you probably know, but you see this number is appearing in the square bracket, 10397. So this is the order of execution of cell. If I have done a equals to this here, you see the number is 105. If I print a, the value of a will be whatever was here because I have run that recently. That's why it's not encouraged that you have same variable names throughout your code. It should be different. But because this is just I'm giving small examples, I've used the same names. So the order of execution will determine what the value of the variable is. So accessing elements. So what is a? Okay, so I have a equals to this. If I say a0, it will give me the first element. First element is this element. If I have one more square bracket 0, it will give me the first row, that is this. And then if I use 2, it will give me the last. So accessing whatever the dimension of your array is, that many indexes you will need to access each element in the multidimensional array. And this thing can also be done like this, I think. So you can either use separate square braces or you can just put 0, 0, 0, 2. This will give me 3. If I use 1, 0, 2, so this is the second. Let's do something else. So 1, 1, 2 is giving me 6. That is the first index array. That is the second. Basically, 1 is the second one. Then the second row. And then the second element. That is the last element. So because it is 0, 1, 2. So accessing any element, we'll have to use such index. And slicing array is similar. We can do, suppose you have 0 and I do this. So this semicolon is telling me that start from the beginning, but go up to the second element only. this is exclusive. So the last element is not printed. So 0th element and the first element is printed, not the second element. If I do 1, then only the first row will be printed as it is starting. If I start from 1 and if I go to 2, only the first element, that is the second element, I should not say first element, the second element is printed, which has the index 1. So slicing, the basic syntax is the start, end, and step count. And if you don't put anything, it will start from start. If you don't put anything in the end, it will end in the end. That basically whatever we do in list slicing, that also applies in NumPy array slicing.
So what happens if I put 1 in the place of step count here?
Then it will just print everything. So 1 is just basically no step, right? It is redundant, so it doesn't matter if you write. Same output. Okay, so the next thing we have are the random functions. So NumPy has, so if you click on this documentation, which I will share with you later. So in documentation, you can see that there are many random functions available. Like we have the random normal distribution, random integer, random Poisson distribution, and many. There is a list. Whatever will be your purpose, you can use these distributions to perform some random array creation. So let's just see an example of what a simple random function does. So I'm importing from NumPy, import random, and I'm taking random dot rand. So this will return a random number between 0 and 1. So this is just a random number, and it is always between 0 and 1. There is another function random dot random integer if I want just the integer. Okay. So it will give me random integer starting from 0 up to 5. If I run this multiple times, it should give me different values, always between 0 to 5. So this will give me random integer. Suppose I say random integer between 0 to 100. I can also give between 20 and 100. So this random integer will always be between 20 and 100 every time I run. And I can also give it a parameter called size. Say if I say size equals to 5, then it will give me a NumPy array of 5 random numbers between 20 to 100. If I say 5, 2, then it will give me a 2-dimensional array, 3-dimensional array. So this size takes in the argument that is basically our np.shape, whatever the output was of np.shape, that we can pass it as a size. So if this, we know how this looks like 2 3 by 3 matrices. So if I use the same size, it will give me 2 such things. And I can assign it to some variable, random integer. So random integer takes low, high, size, and data type. We can also give if we want some another data type. And after this, there is also random choice that I can show, but random choice, I mean, I don't have much opportunities to use this, but there is something called as random choice. So if I have 1 2 3 4 5, it will just select any random number from this list, NumPy array. This random choice can have size parameter as well. So it will select any random numbers from this list and use it to create array of whatever size we mentioned.
Can you have
And
non-sequential numbers in the list?
yeah, anything. Anything is fine.
Sir,
Sorry?
can we make choice like suppose I want to make array between 20 to 100. I can take random numbers, but I want to eliminate a number, certain number like 50. So can we add that into the code?
Eliminate 50 from this.
Huh.
I'm not sure. We'll have to use some if logic or something to filter that out.
Okay, sir.
Yeah.
So are these based on random number generators? Like you have like
Yeah, it is. So there is no true random generator. It's always a pseudo random generator. So there is something called as random.seed. I was not going to tell, but random.seed, and we can place some seed value which will be used by the inbuilt random number generator to generate random numbers. So if I use some seed value, every time the same numbers will be generated. So this is useful when you want to share a notebook with someone and you want to have same results of your distributions. You can use a seed count. So this seed count will be used by the random number generator.
So what is the source for this?
Source for the random number?
Random.seed. Is
What
it
do you mean?
okay, in the sense ki why like for example, if you're using any kind of function like random word random to generate a particular number, how is that number is it hardware based or is it like how is that generated?
So NumPy has this pseudo random generator in it. Let me just check in the documentation also. Where is it?
The simplest way to take random seed is take the time of the machine.
So see, it uses this generator. The function random will instantiate the generator with NumPy's default bit generator.
Okay.
So if you want to deep dive into it, just go to just Google random seed and go into bit generator. You can see what they use inbuilt inside the code base.
All right.
Whatever the random seed value we put, it is passed as a seed sequence so that it begins from that value and creates a random number.
Sure, I'll go.
Yeah.
Thank you.
So apart from this, there is a random dot rand n. If you see, it returns a sample from the standard normal distribution. Yeah.
So in the previous example, for random.int, you were given defined between 20 and 100, no, sir? So in this example, the size first value for the input of size is 2. So we're having two set of arrays with 3 cross 3 matrices.
Correct.
But in the last example we wrote, the first element for the size is 3. So shouldn't we need to have three elements with 3 cross 3 matrices? But we had only one, sir. The last example, sir. Last example we did. The recent example we did. So size value is 3. So shouldn't we need to have any 3 cross 3 set of elements with 3 cross 3 matrices?
No, see, there are two indexes, right?
Yes, sir.
So basically, it will be a two-dimensional array. So what this says is there will be 3 rows of 3 elements each. We have 3 rows of 3 elements each. What this is saying is we will have 2 elements, each will have 3 elements, and each of the 3 elements will have 3 elements. So basically, we have 2 elements, one is this and one is this. Each of those 2 elements have 3 elements, that is the 3 rows. And each of the 3 rows have 3 elements, that is 88, 32, 35.
You can show example of 3, 2, 2.
So what this will have, we will have 3 different NumPy arrays. We have 3 arrays. Each of these 3 arrays have 2 arrays. So we have 2 arrays. And each of those 2 arrays will have 2 elements. That is these 2 elements. 66, 39. 6359. So it is top-down view, like 3 arrays, each of 2 elements. Each of those 2 elements will have 2 elements.
Thank you, sir. Got
So
that.
this 3, 3 will have 3 elements of 3 elements, like that. Okay, so in random there is random n. Random n stands for random normal distribution. This is a standard normal distribution with this mean of 0 and variance of 1. I can do np.random.random, and if I say 10, it will give me 10 values from the random normal distribution. This is useful when we need some specific distribution random values. Other random values you can explore from the documentation. I'll attach the link to that in the notebook that I'll share. Okay, so the next thing is the most important functions in NumPy is np.arrange. It is not arrange, not ARR. It is arrange and linspace. Linspace stands for linear space. Let's just see a quick example of how it works. So arrange is basically just like in Python, you have that range function, like I used for I in range 10. But arrange is in NumPy. So it starts from 0, ends in 10. It will give me 0 to 9, but in NumPy array. I can also have step count, just like range. And in this, I can also do minus np.py.
Mummy!
Plus, sorry. Minus np.py to np.py. This will give me these values. And if I say I want 100, sorry, this is not, this is a difference of 1. So minus 3 to 1, I can say 0.1. It will give me 100 values. It's not 100. How many are this? 100 values maybe. So in a range, the syntax is the number you want to start with, the number you want to end with, and the difference between each of those numbers.
Sir,
So
but
in
why
this
it
simple
didn't
example,
end? The output didn't ended with 3.14 but 3.05.
yeah, because as I said before, in Python, it is reflecting this everywhere, that the first element is inclusive, the second is exclusive. So if you want 3.14 to be included in the end, you need to do plus whatever your difference from. Then you will have 3.15, which is more, a bit more actually.
Okay.
What happens here if we didn't give the step count, sir? Like that zero, if there is no 0.1, what will be the result, sir?
It will give some, I think the default is 1 itself. Yeah, the difference is 1, default difference.
Yes, sir.
Now let's see the difference between linspace. So in linspace, we can have linearly spaced values. Let's take the same example. So here I said that I want the difference of 3, right? 3, 3, 3. If I put 3 here, it doesn't give me difference of 3. It gives me 3 linearly spaced values between 0 to 10, but in linspace, this 10 is included. So whenever you want to use inclusive values of both of these things, we use linspace. Linspace stands for linearly spaced values. So in that we can use np.py, and I want 5 values between them. Then these 5 values are linearly spaced. What that means, the first and the second element difference is the same as the second and the third element difference. The difference between all of these elements is the same. And I can put 50, it will give me 50 linearly spaced values. It will start by minus pi and it will end with pi inclusive. So whenever we want inclusive values, we use linspace. Notice the difference between linspace and arrange. A range gives us same difference and exclusive of the last element. Linspace gives us same difference, but whatever the count of values we want between them. If I say 4, then it will give me 4 values between 0 and 10. Is this clear? Okay, I'll take that as a yes. So in NumPy, there is a quick function to convert between radians and degrees. So suppose we have x equals to np dot array. We have these angles 0, 30, 45, 60, so on. We can convert them to radian by just saying np dot degree to radian. This is the function deg to rad, degree to radian of x. And we can print radian values. So these are radian values. In NumPy, there is sine and cos. So np dot sine 30. So sine 30 does not mean it is sine of 30 degrees. It is sine of 30 radians. If we want degrees, then we will have to write np dot sine np dot radian to degree 30.
No, degree to radian.
Sorry, degree to radian. So now this is converting 30 degrees to radians and it is giving us half.
Sir, is the default value will be in degrees, sir?
In radians. Default is in radians. So whatever we put np dot sine 30, the Python is considering 30 as radian, 30 radians, not as degrees.
Okay, sir.
In all of them, or whatever. Okay, so if I know I've went like quickly through all of that, but in the notebook that I will share, you'll have more examples like this and maybe a few more things that I've just skipped through in NumPy. But we'll quickly see matplotlib and how to plot basic plots. So matplotlib is the plotting library in Python. It is similar to matplot.
Can I interject, Pratik?
Yeah, sorry. Yeah.
Because we have 2 minutes and
Okay.
then
Okay.
next session will start in time. We will have more time in the next section. So
Okay.
So 2:30 we can start with matplotlib and then
Okay, that's fine. Yeah, that's fine.
One last question.
Yeah.
So since the default value is in radians and we
Mhm.
are comfortable in working in degrees, so can we write like np dot cos 30 by pi
np dot cos 30
by pi?
Yeah. That will work. If it's too much, you can also define your custom function to just convert everything into degrees by default. So maybe that we can give as an assignment. So Jigar will cover how to write functions in the next session. So yeah, any
Thank you,
questions
Pratik.
about all of this? Yeah.
So we'll meet for the next session at 2:30.
Sure. Thank you all.
Thank you.
Thank you, sir.